All right, and we are recording. So, Avi, thank you so much for coming back on. It's a pleasure to see you again,
Thanks for having me. It's a great pleasure to join you.
and a lot to discuss. Uh, I'd love to talk about your research, your recent research, and help me fill in the gaps here. In 2014, a meteor fell near Papua New Guinea, and years later that then dovetailed into research that you did, where I think, and again, jump in, stop me if anything I'm saying is incorrect or if I got it wrong. But that meteor was an impetus for you to start research, and some of the research suggested that that meteor could have extraterrestrial origins based on some of the seismic um, data that you found. Can you teach us what you and your team discovered that you'd like for
Right.
people to know about?
So let me start from the beginning. A decade ago, on January 8th, 2014, US government satellites had sensors that detected a fireball over the Pacific Ocean, 20 kilometers above the ocean surface. There were 3 detonations. They saw the light. Okay, nothing to do with seismometers or detectors in the area. Okay, so they saw the fireball and localized it to within 11 kilometers region. I decided to lead an expedition to check any materials from that meteor, because the velocity of that meteor indicated that it came from outside the solar system. Okay, and 2 years ago, the US government, the US Space Command, issued a letter to NASA confirming that indeed they double-checked the data, and at the 99.999%, the velocity measurement of this meteor indeed indicates that it came from outside the solar system. It's interstellar in origin. So we wanted to find the materials from this object. We went to the location of the peak brightness of this explosion, as reported by the US government. Okay, and we found materials using a magnetic sled on the ocean floor that we later analyzed in the laboratories of Professor Stein Jacobson at Harvard and Dr. Roald Tagel at the Bruker Corporation in Berlin. It took us 8 months to do the analysis. We found altogether 850 spherules. These are molten droplets from meteoritic materials. Out of those, we found that 78% are of meteoritic origin familiar to us from solar system meteors. These are background spherules. And 22 are of a type that we call differentiated, where some elements are missing and other elements are enhanced significantly. And then among those, about half are of a type that was never reported before, where you have abundances of beryllium, lanthanum, uranium that are up to 1,000 times more than in the material that made the solar system. Okay? And they were never reported in the scientific literature before, so we gave them a name, Belau spherules. And to us, it indicates an extrasolar origin, because such spherules were never associated with meteoritic material before. Okay, so we argue just the chemical composition of the 80 or so spherules that belong to this type that was found in the location that the US government provided for this fireball suggests an independent evidence that it came from outside the solar system, on top of the fact that the US government reported the velocity that is beyond the escape speed from the solar system. And that claim has been disputed by a number of very aggressive scientists, at first saying the government data about this meteor should not be trusted. We don't believe it. Then there was the letter from the US Space Command to NASA confirming that they double-checked the data and they stand behind it as being the object being interstellar. That was after this pushback. And then when we went there, we were told by some scientists, the same scientists that are now attacking the project, they were saying, you will not find anything. So then when we found something, there was a paper published. Oh, we still don't believe the US government data. They measured the velocity of this object to be too high. In fact, it's 3 times slower, because only then we can fit it with models for solar system stones. And to that I say, well, if your model doesn't fit the data, it doesn't mean that you should dismiss the data. It means that you should maybe consider a different model, because why should everything in the universe be made of stones that you are familiar with? Okay, so objects from outside the solar system could be different than the ones you find in the solar system. That's a sense of being modest, not assuming that you know everything, that if something new comes along, you should be updating your knowledge. But they are not willing to do that. And then they said, oh, you actually found coal ash. And by saying that, I mean 2 papers written by the same people arguing that we found coal ash. And so we checked 55 elements from the periodic table showing definitely that it's not coal ash. I published it in a research note just to respond to this claim that it's coal ash. It's not coal ash based on the element. I mean, we get some elements that are a factor of 10 to 100 more than you find in coal ash.
Why haven't they retracted their statements in that case?
So then every month or so, they change the argument, okay? So now they're saying, oh, actually, the seismometer data was a track, but they don't relate to the fact that we chose the location of the meteor primarily based on the US government satellite data, okay? It has nothing to do with a seismometer on Manus Island. And besides, by the way, they cannot say for sure it was a track. They just say it's possible that it was a track. And for them to claim that we went to the wrong place, because if they ignore the US government data, they don't know where the meteor fell to within hundreds of kilometers. It's just not honest, because how can you dispute what someone else did based on US government data by saying, I want to ignore that data, and based on other data, I don't know where the meteor is. That is not logical. Yet that's what they did, put an unrefereed preprint on the archive, and moreover, had a press release that was widely distributed to science journalists, misleading them of the facts. And when I tried to explain that we went to the meteor site based on US government data, some science journalists prefer to ignore that. Now, what can I do other than explain it? So on the same week where all these reports came out, I explained that we based our location for the meteor on US government satellite data. And one more thing that then they said is, oh, actually, we don't trust this data because the US government gave 2 locations to the meteor. And I explained one of the locations is the flash that was observed when the meteor first encountered the Earth's atmosphere. That's the entry flash into the atmosphere. The second position was the peak brightness. That's where most of the energy was emitted from the explosion. And we went to the peak brightness location. Why? Because that's where you will find most of the debris. And the 2 locations are different, obviously, and they line up with the velocity, the path, the trajectory of this meteor. They line up with the direction of motion, the 2 points. Yet in the paper of Fernando and in subsequent tweets on X, the same people, Fernando and his colleagues, were saying, oh, the government gave 2 locations, therefore they don't know what they're talking about. Even though I explained that these are different, because one of them is the entry into the atmosphere and the second one is the peak brightness. And in the official catalog of NASA, the peak brightness is what is cataloged, because that defines the location for the debris. And that's why we went there.
I think fortunately for you, Avi, to tell me what you think about this, is that with the scientific process, eventually everyone comes around to the truth, right? I think some of the biggest theories of the century, Einstein came out with a theory of relativity, and then it was only a decade later that it was accepted. But but I think acceptance of the truth is inevitable. And so in your case, despite the frustrations that you have to deal with and these from these other scientists, assuming your position is correct, they will have no choice but to accept it eventually, right?
Well, I hope so.
Does that comfort you to know that given the scientific process, that eventually there is no refuting?
Yeah,
What someone
that's what I hope, So there is this approach of the eagle that I'm trying to imitate. The eagle often has crows pecking on its neck that are sitting on its back. And instead of fighting off the crows, the eagle rises to the greatest heights where the oxygen level is low and the crows drop off the back of the eagle. This is my approach. I am not mud wrestling with those people. I've never met personally Steve Dash. But what I can imagine, Steve Dash from Arizona State University, I imagine that day and night, every day before he goes to bed, he thinks about me. Every morning where he wakes up, he thinks about me because he's completely obsessed with my work, putting all of his effort into disputing each and every possible angle of what I'm doing. He's completely obsessed. And now my daughter explains that to me. She says, whenever, someone gets to be famous, there are haters. So he's a hater. I never met him in person. I never tried to mud wrestle because that would get me dirty. I completely ignore his aggressive attacks. And there was a conference to which we sent a student. Steve Dash was in the front row, ready to attack whoever speaks about the expedition. It was a student. And the attacks were directed on the student, a graduate student from Harvard, that handled it very well. But my point, as you just pointed out, is that scientific knowledge is gained by attending to evidence, not to opinions. Okay? And last week, there was a reporter that approached an organization called World Minds, where I'm a member, which is very prestigious. And the reporter asked, why is Avi Loeb, who appears to do some research which some people regard as controversial, why is he a member? And the answer was because even Albert Einstein was controversial between 1905 and 1915. Okay, so whenever you break the mold of conventional thinking by opening up a new frontier, it comes with a territory that you get a lot of resistance. And nowadays, the resistance is far more vocal because of social media, where people come together and devise ways to destroy any construction, any flower that rises above the grass level.
Yeah.
And then you hear from different people. You hear from Fernando as if he's completely independent of Steve Dash, but he's not, because Steve Dash is on his paper.
Right.
Okay. And then you hear from a third person, but he's not independent. These are all people who speak among themselves and try to devise ways of making negative remarks. And for people from outside, it looks as if, oh, these people all came with criticism. But what I'm saying is that they have an ulterior motive.
Yeah, it sounds like it. So the good news is, if you were, let's say, a politician or someone else, then your reputation ultimately would be at the whim of the masses or what people think. But because you're a scientist, I think eventually everyone's opinion will conform to the scientific reality.
Well, that's the hope.
In your favor, and so you can,
well, that's the hope. But what there are historic examples where it took a long time for the scientific community to adapt to the facts, and I think the situation is exaggerated now, exacerbated by social media and the way that reporters are not attending to facts and are sometimes swayed by opinions, and that worries me, because it has two effects. One is it suppresses innovation in science, because young people that have innovative ideas are afraid to go in those directions because they would be attacked immediately by people like Steve Dash. And just think about a young person that doesn't have tenure. If you were to have a very vocal critic of that nature that basically tries to kill any new idea that deviates, just saying that maybe we found stones that are different from solar system rocks. Like, why is that so heretic? But that is sufficient reason for those people to try and demolish the argument in any possible way. And so, I think it has a very negative effect on innovation in science. And secondly, on people, ability to, to listen to what the facts are telling them. Because if they have all this noise in the background, if people are raising dust and claiming they can't see anything, then because they raise dust, nobody else can see anything. But they raise that dust for no good reason. They just don't want to see anything. So my point is, instead of them letting us do the work of the analysis, in the middle of the analysis, even before the analysis, they were making negative statements. So that's my concern, that the work of science, as it should be done, is being suppressed by bullies.
Well, that's tough. It sounds like it's great that in spite of those bullies, you're still you're moving forward with the work that is important.
Yeah, we are doing the work, yes.
So thanks for walking us through that. You're a esteemed professor at Harvard, and the Harvard professor recently was fired for refusing or not being able to condemn anti-Semitism. Can you speak to that, your thoughts on those events?
So that was very unfortunate, because it created some turmoil within Harvard, and in a way it was a result of friction with the outside world, triggered by the October 7th events in Israel. And I met with the interim president at Harvard that replaced the previous president, Claudine Gay, who stepped down, and I greeted him as the last man standing. And I proposed 7 points that I think Harvard should adopt for a better future. The first one is to adopt political neutrality on campus. That was recommended by the Calvin Report at the University of Chicago 57 years ago. And I think it's really important for an academic institution to focus on scholarship, not on adopting a political stand. Because if the country is divided on various political issues, we should make the academic environment open to all sides of the argument, okay? But not through disruption of the academic education or research by groups with a political agenda. So in fact, the second point was to ban disruption of academic activities. And at Harvard, what happened was that there were protests that interrupted classes, lectures, people walking on campus felt threatened. That should not happen. In fact, Harvard had those rules, but they were not enforced. So I think academic scholarship should be maintained and not interrupted by political protests. And then an important item is to select faculty, students, and administrators based on excellence without a political agenda regarding the statistical outcome of the search. And so that means that we should remove barriers for success that are based on socioeconomic background, ethnicity, gender, sexual orientation, political affiliation, and so on. Because fundamentally the laws of nature, from a physicist's point of view, the laws of nature can be discovered equally well by Republicans and Democrats. Okay, so there shouldn't be a situation where we have our favorites for the scientists on campus based on political stance. That should not be the case. And
so take out of it. Takes politics out of it.
Politics out of it. Select scholars. That's the fourth point. That reflect the balanced diversity of political opinions within society. If campus leans to one extreme of the political map, that would alienate some students and faculty. And academia, in my view, must alleviate rather than amplify societal polarization. And to do that, it needs to create an intellectual atmosphere and that accommodates both sides of the political map. So currently at Harvard, only 2.5% of the Harvard faculty identify themselves as conservatives in the 2023 survey by the Harvard Crimson. 2.5%. The next point is that one should streamline the growth in the population of administrators relative to scholars. Since I came to Harvard 30 years ago, there were new layers of administration that were added. And it changes the mentality because, in my view, administrators are supposed to serve the scholars. But during the past few decades, the distance between the faculty and the top leadership increased by these new layers of administration.
Wow.
Another important point is to enhance free speech and innovation by rewarding creative individuals. That relates to what we discussed before. It's important to foster dialogues among people who disagree with each other, but they should disagree respectfully, not by protests that disrupt the academic activities. And finally, one would like to establish mechanisms for transparency and feedback where the missteps by the Harvard leadership can be corrected. Most importantly, the corporation that currently controls Harvard and is not held accountable. Nobody looks over their shoulders. And, in particular, Harvard's president should be engaged in attending ad hoc committees for tenure appointments, in fact, attending faculty meetings. Academia is not a commercial enterprise. The top management must be in steady contact with the faculty and students because non-university business is more important than attending to the members of the university.
Absolutely. Yeah, I think those are great points, and I hope that they embrace those suggestions that you gave. It sounds like it could really help the university. What are you most excited about in your work or at Harvard over the next 12 months?
Yeah, so first we are planning the next expedition to the Pacific Ocean to look for bigger fragments, bigger pieces of this meteor, because that could prove its nature, and also if we have enough material, we can date the age of the material based on radioactive isotopes. And so we are in the initial phase of deciding which instruments to use for that. It will be more expensive because there are fewer bigger pieces than those millimeter-sized spherules that we found. So that excites me. If we go there, it will be very exciting. The previous expedition was challenging, but it was fulfilling to actually go after the materials, bring them back, and analyze them. A lot of work, by the way. The second thing is that the Galileo project that I'm leading at Harvard University, we have already a functioning observatory that is collecting data 24/7 in the infrared, optical, radio, and audio. We are monitoring the sky because the US Director of National Intelligence said that there are objects that the military is unable to identify. These are unidentified anomalous phenomena. So, they might identify most of them, but for us as scientists, even if 1 in a million came from outside of this Earth, it would be big news and will change the future of humanity. So we have a functioning observatory that already looked at hundreds of thousands of objects. So far, nothing anomalous. We are able to identify them. But, time will tell if there is anything unusual that shows up in the Boston area. The observatory is located at Harvard. And then we are assembling a new observatory in Colorado. And we just got the funding last week from the Richard King Mellon Foundation, very prestigious foundation, to build another observatory in Pennsylvania. And we will start the process soon. So we will, hopefully within a year, we will have 3 observatories collecting data. And, the sky is not classified. And if we see anything unusual, we'll report to the public. So these are the exciting research programs within the Galileo project. The next expedition and establishing these observatories that I very much look forward to. I should say that last month I was invited to speak at the Munich Security Conference, which is a political event bringing heads of state and high-level officials every year. And in fact, when we had a drink on the roof of the building, there were snipers there with black head covers. They were not there to protect me. They were there to protect Kamala Harris and Volodymyr Zelensky and other heads of state, which shows you that searching for extraterrestrials is less controversial than being a politician. And so I spoke there for 45 minutes about space. And then a day later, I went to Poland, the town where Nicolaus Copernicus was born 550 years ago. The Polish government organized a special celebration, and they invited me to give a keynote lecture. And I titled this lecture, "The Next Copernican Revolution," by which I mean that the first Copernican revolution was that we are not at the center of the universe. He realized that the sun is at the center of the solar system. And the next Copernican revolution, in my opinion, would be for us to realize that we are not at the intellectual center of the universe, that we have a neighbor, a cosmic neighbor that we can learn from. And that's, I'm looking for objects that may have been launched by other technological civilizations and arrived at our backyard.
Incredible. And we will be looking out for the results from all this work you're doing. Sounds very exciting. And maybe in a few months or a year from now, there will be results to show from these expeditions.
Thank you.
So Avi, thanks for your time. Let me stop the recording, and then maybe you and I could wrap up for a couple minutes.